Hi everyone. Did you guys at the back end can hear me? Perfectly? Good. Hi everyone, good evening. I'm AJ from Teneo. We help customers and businesses to sign their documents using their EIDs. It's pretty simple. I've been working as a cloud infrastructure engineer ever since 2016. And along with me, we have our rockstar developer, our Mr. Amit Raja, who's been working with us ever since the Big Bang of Teneo in 2013. So, we'd like to tell a story. Our story dates back in around 2016 when I joined the company, and my job was pretty simple. Just get in there and provide Ahmed with a platform he could deploy his services into. So I went crazy and started to do an infrastructure as code-based project using Terraform, and I failed miserably, and I had to drop it. The reason I did that was because I didn't consider going through the basics first before even considering to take measures in such an ambitious endeavor. That I didn't consider working with the developers first in providing them a streamlined deployment process to begin with. So I took Ahmed with me and we sat back to take things into perspective and to see the real problems we were facing through. The real problems that were keeping him from deploying things in the easiest way possible, and the same problems that were keeping me to provide him with a infrastructure that could be as automated as possible. So we realized these so-called problems, and the first problem we stumbled upon was this guy over here. Yep, what do you know? I became a problem. I became a problem because every time a developer wanted a new piece of instance to deploy their services into, they relied on me. Every time a manual escalation on some service was required, they relied on me. Every time a developer wanted a new piece of cool technology in order for them to be able to deploy a new service into the production arena, they require AJ as a service. In the same manner, we have a high dependency on developer guy. And who better to explain it than the rockstar developer himself, Mr. Ahmed? Will you take it away, please?
I told him not to say that. All right, so like AJ said it, we started off by getting inspired by all these new technologies, Kubernetes and Terraform and all that, and having a separate project in parallel, and of course it failed because it wasn't really connected with reality. So we took a step back, and of course we saw one problem. It was the dependency on the ops guy, and we had a dependency on the developer. Now, like Stefan mentioned, back in the old days, there's one person who can SSH into the servers and can do all the magic stuff. And this guy had all the access. And when a new guy joins in, or a new person joins in, you don't give them the same access. When they have to release a feature, they go through this person. And now he has that elevated status, right? Just because he has a bunch of private keys on his machine. And once he deploys something, what happens is he forgets something. What about staging? What about testing? And of course, this guy becomes a bottleneck, and of course, that doesn't really scale. So we said, okay, and another thing was that what would happen if things break? Now, let's say you release something one day, and in the middle of the night, something breaks. Who takes responsibility? Is it the dev guy? Is it the ops guy? It was kind of a mess. So we said, let's give it some perspective. Let's draw a line between development and ops, and let's see how we can assign responsibilities and how we can hold people accountable for certain things. So let's look at how things were a couple of years ago. So keep in mind, this is a monolith application. We decided not to change the application itself. We were just trying to give it we were trying to come up with an interface between development and ops. So back in the days, we had the developers were responsible for writing the code, of course, and the host was responsible for the operating system and the libraries. And in hindsight, you can fix this problem with Docker, but back in the days, that wasn't a common thing. Furthermore, the host was also managing the configuration. So if you had to horizontally scale the thing, you would have to manually fiddle with the configuration. We didn't have secrets manager. On top of that, the host was also responsible for resource monitoring, CPU, memory, all that. It was also responsible for monitoring the host level logs and also the service level logs. To come up with a better separation of concerns, we said, okay, first thing is we move the libraries over there, That is something that we can fix with Docker. We said if you have to release a service, you also have to specify the configuration with it. How you do that, I'm going to get to that in a bit. And we also decided that if you are creating a service, you are responsible for handling the logs. So we move the logs on the service plane. Now that means that if it's your service, you're going to redirect the logs. If there is an alarm, you're going to get it and you're going to be responsible for it. The host isn't going to be responsible. The ops person won't do anything about it because they don't know that domain. You know the domain, you're responsible for the domain. So looking at this picture, the code and the libraries, that's of course a Docker image. But this whole package that you give to the ops person to release on any host, we call that a release artifact. Now there's a problem with this release artifact. How do you keep configuration that has secrets in there in the same package? How do you do that? So let's look at how we package the release artifact. We had a release artifact repository, which we had in GitHub. And every release artifact had two pieces of information. There was the Docker compose file that was pointing to the Docker image, and then there was a configuration URL. Now this was just a pointer to the configuration. This doesn't give you the access to the configuration. It just lets you fetch the configuration if you're on the right server. So if you have an IAM policy, you can fetch it. Otherwise, you can't do anything with it. What this means is that me as a service owner, I can go and change the Docker image and reuse the existing configuration. And since configuration doesn't change that frequently, this worked out pretty good for us. Like 81% worked out for us. Docker Compose points to the Docker repository, and then the configuration just gets some configuration from S3. So in our case, it was S3. We kept all the configuration encrypted. That's our layman's way of doing secrets management. So let me emphasize again, we weren't trying to change this. We weren't saying, okay, let's introduce key management over there. We were just saying, okay, let's give let's make an interface between the service and the ops, and we're going to change the other pieces as you go along. We need to take incremental steps. So how was this actually working out for us? On the left side, you have the development plane. On the right side, you have infra. A developer comes in. He has or she has the Docker image. They go to the release artifact repository. They create a new pull request and assign it to the ops guy. And this ops guy goes into the target host and does that deployment, pulls the Docker image, pulls the configuration. Now, we created a process where anybody was able to create a new release, but we still had a dependency on the ops person, and it wasn't really scalable because he was still doing some things manually, logging into the target host and doing provisioning. And how did we scale that? And how did we remove that dependency? Who else than the rockstar ops guy?
Thanks. Nice transition. All right, as Ahmed just told you, we came to an agreement. We set up the rules of the game. We implemented the build release process as the way to go for streamlined deployments. The problem was that I was still the guy doing the actual deployments on the target EC2 instances. And by definition, though it was pretty easy for me to do that on every EC2 instance, it didn't scale. It was just tedious and cumbersome. And in a scenario with several EC2 instances, dealing with a single service, it was just a pain. So I needed to provide not only me, but also developers the power to release services as a single whole unit that could provision automated infrastructure that was always scalable and that was already running any service that they wanted without having to rely on me. So the high traffic peak season, as we call it, the accounting season, was approaching in 6 months. And I had to come with a fast solution so that developers had had enough operational agency to release services whenever they wanted. That included infrastructure, the release process automation, and that was also auto-scalable. So that's when service units came into play. And service units is just a made-up term. Bear with me on this one, not to be confused with system-based service units. But service units are nothing more and nothing less than a group of AWS resources They are meant to host a service inside a Scaleberry platform. So they can be broken down into one main network load balancer that is attached to a single target group whose targets come from another scanning group. All the scanning events come from CloudWatch, and upon boot up, instances are programmed through user data to automatically execute the be-release process. The lifecycle and implementation is actually done by a Python-based utility that I made that relies on CloudFormation for the same matter. With this tool, developers can create, destroy, and put services online as service units without having me to intervene. So how does this work? With Sonic now on the table, a developer would just have to go to a Bastion server. This is temporary as we figure some API in between. And we'll have to, let's say he wants to release a new instance of API wherever in production. So he will have to then run the Sonic launch command specifying the service in question and its version. And what Sonic is going to do behind the scenes is that it's going to gather the release artifact for that service and version, only require an additional YAML file for configuration of the service unit called sonic.yaml. And this file is going to tell Sonic how to properly deploy the service unit. And once Sonic gets the data from the configuration file, what it's going to do is that it's going to render a CloudFormation template from which it's going to call CloudFormation and generate a whole new stack, finally deploying the actual implementation of the service unit. And that creation takes about 3 to 4 minutes from the ground up. And now it's just a matter for the service to be actually put online. And in order to do that, a developer will just have to add an additional command. This time would be Sonic attach. Once again, specifying the service in question and the version he wants to release. And what Sonic is going to do this time around is that it's going to talk directly to Thread 53, and it's going to modify the designated DNS record for that service unit so that it points, or better said, so that it's being added to the DNS name of the service unit network load balancer. And once that has been done, the service comes officially online and serving requests. In just a matter of 2 commands, by total operational agency of the developer, we don't have to worry about the inner workings of what's going on. He just has to worry about getting that thing out there in production environment. So what did we learn from all of this? Name of the game, one small step at a time. Easy does it. Being the first step, defining an agreement. Ahmed and I coming to terms and define the rules of the game that allowed us to have a schema in which we could then define a way to streamline deployments. And that implementation became the BRP process. In this manner, now developers could easily deploy services, but it didn't scale. So I had to then act upon the automation of the infrastructure on the line. And that's when service units came along. Now developers could have total control of the lifecycle of infrastructure in services, in any environment they wish. And this whole thing has inspired us to look forward, very likely to have our own platform as a service API, an abstraction for the benefit of developers, so they can do their stuff without having to worry about the underlying platform, and so that the ops guys can work on such platform in the way they please, without having to worry about developers. And that's it. This is the end of our so-called campfire story. If you got any questions, you can let us know afterwards in the mingle. And yeah, this is AJ, and I'm signing out. Have a nice one. Thank you.